Hey everybody, and welcome back to Front-End Expert. In this video, we will be discussing promises within JavaScript and how we can deal with asynchronous code. So a promise is simply an object, and the idea of a promise object is that it contains the value for some asynchronous operation. So this is going to be an operation that we oftentimes don't yet know what the resulting value is. So this object has a state. And the state can have one of three values. So it can be pending, which is just that. It means that the value is still pending. We don't know what it is yet. Or it can be fulfilled. And fulfilled means that the operation was successful. Whatever we were promised actually happened. And finally, we can be rejected. And a rejected promise is very similar to having thrown an error. This is saying that whatever was promised did not actually happen. For example, if we were making a request to some web server and that request never came back, or it came back with an error message, it would be a rejected promise. So to create a promise, what we can do is we can just say const promise and set this equal to a new promise. And the promise constructor is going to take in a function. So this function has two values or two parameters. It's going to have resolve and reject. So the resolve and reject parameters are both functions, and these are functions that can be used to change the state. So for example, I could say resolve, and let's resolve to a value of 2, and what this is going to do is it's going to change the state to fulfilled and change the value to 2. So now if I were to console.log out the promise, you'll see that we get the promise with the value of 2. However, if I commented out line 4, what we are going to get instead is a promise that is pending. So this is the default state of the promise. It has neither been fulfilled nor rejected, so it is just pending with no value yet. We could also reject here. And when we log out the promise, you will see that it has thrown an error, so trigger uncaught exception, essentially saying that we have a promise and it was rejected and we did not catch that error. We will see in a moment how to catch the error, but for now, let's just go back to a resolved value of 2. Okay, so next, what I want to show is the asynchronous nature of a promise. And the promise code, so the code inside of this function that we pass to the promise constructor, is completely non-blocking. So, for example, we could say set timeout, and let's do the same thing. So we're going to resolve the promise to 2, but we're going to do it after 1 second. And you might think that, okay, we need to wait for this promise function to finish for it to resolve before we move on, but that's not the case. This code will finish running, and you'll see that when we console log promise, we get the value of pending because of the fact that this happened immediately and the promise was not resolved for a full second. However, we could do set timeout, and let's console.log the promise in this timeout. So we can say console.log promise, and we can do this after, let's say, 1500 milliseconds to make sure it happens after the promise has finished resolving. And now when we run this code, we log out pending, but then we log out the promise with the value of 2 in the timeout after 1500 milliseconds, because by the time we get to this function call, the promise has already resolved. Okay, so now you might be saying that this set timeout feels like it's not the best way to do this. We're sort of hard coding in this idea that the promise will be resolved within a second or 1500 milliseconds actually. But how do we always know that? For example, if the promise was being used for a network request, we wouldn't know how long it's going to take. This set timeout method isn't going to work. So what we can do instead is remove this code, and we can call a function on the promise object. The promise object has a function called then, and what this does is it takes in a callback function that has a value, and then you can do anything with this value. So for example, we could console.log the value. And what this is going to do is it's going to wait for the promise to settle, meaning that it's waiting for the state to change away from pending. And when the promise settles, it calls the then function and it passes in the value. So if we resolved with a value of 2, then this value becomes 2, and it just calls this function. So now when I run this code, you will see that once the promise is resolved, we log out the value of 2, but we do not log the entire promise, so all the then function gets is the value, not the entire promise. And then can also take a second function, so I could add one more function here, and the purpose of this one is for the error message if we reject. So for example, I could say error, and let's console.log, oh no, and then concatenate that to the error. And then what we can do is reject this promise, and let's reject it with a new error and say something went wrong. Now when I run this code, you will see that we get, oh no, error, something went wrong. But of course, if we change this back to resolve and add a value, let's say 2 again, then it'll console log out 2 because it goes into this first function since it was a resolved promise. Now with this first function, there is a little bit of a nicer syntax that we can use. So then takes in a function, and that function needs to have a parameter of a value, and then it needs to do something with that function. And in this case, we are passing the parameter into the console log function. But this is essentially the same thing as just the console log function. We have sort of just created a wrapper around the console log function. So all we actually need to do is just put console.log here. And the reason for this is that console.log is itself a function, and it will log out whatever the first parameter passed to it is. So this will end up doing the same thing, and you see that we will once again end up logging out 2. And next, there's also an alternative to this second function here. So rather than having this function here, I'm going to copy this and remove it. What we can do instead is we can add .catch and pass in the function like this. And you will see that we end up getting the same thing. So we log out 2, but if we reject, then say new error, oh no, something went wrong, then we are going to get the promise, oh no, error, and then we have, oh no, something went wrong, because that's the message that we put in the error message. I'll remove the oh no, so we only have that once, and we will end up with, oh no, something went wrong. So this .catch is going to work essentially the same way as having a second parameter to .then. But then the question is, how is this working? How are we chaining these functions like this? And the way it works is that the then function returns itself a promise. So it's going to take whatever we do in this then function, so within the callback function that we pass to then, and whatever the return value is, it's going to return a new promise with that value. And in the case the promise was already rejected, it's just going to pass that value through. So it's going to return another promise with the same rejected state and the same value for why it was rejected. And catch works the same way, except it only deals with rejected promises. So if the promise was rejected, we will go into the callback function within catch, and then we will return a new promise with whatever the value returned by catch is. However, if the promise was not rejected, catch will simply pass the value through, and it will return a promise with the same value as before and the same state as before. Now, in addition to this new promise syntax, so creating a promise with the promise constructor, we can also use const promise and set this equal to, and we can call promise.resolve or promise.reject. And these are functions that return a settled promise. So rather than being pending, they will already be resolved or rejected. So for example, I could say promise.resolve, give this a value of 3, and then let's get rid of this code up here. And now you'll see we essentially get the same thing. So we end up resolving the promise with a value of 3, and we log it out. But when we log out the promise on line 5, it's not pending. It is already a value of 3. The reason being that we never had a pending promise. We created the promise already having a resolved state. And in this promise.then chain, we end up calling the .then value, and we never call the catch value because the promise never gets rejected. Now let's remove this code, and let's take a look at how we can start to chain even more of these promise.then calls together. We can say promise .then. And this then is going to get the value, and we can do whatever we want with it. So for example, I could say value times 2. So now what this is going to do is the promise is going to resolve, and it's going to have a value of 3. Once the promise is resolved, it calls this then function. The then function will take in the value. So this will be 3. So it's going to return 3 times 2, which is 6. But then is going to convert that value to a promise. So it's going to be a fulfilled promise with the value of 6. And what we can do with this is we can chain it to another then call. So I could say .then, and let's take the value here, and let's add 1 to it. So we can say value plus 1. So now this is going to take in the value of 6 that was returned by this then chain, and it's going to take it into this callback function and add 1 to it and return that as a promise. So now we have 7. And then, for example, we could say .then and simply console.log. So now what's going to happen is we're going to take in the promise returned here and pass it in as just a value to console log, and it's going to log out 7. So now we can see initially we log out the promise with the value of 3, but then after the then chains, we have just the value of 7 at the end. Now, syntactically, one way you usually see this is with each then on its own line. So it just looks a little bit cleaner, and you can see all of the different functions that are being called. And then usually what we tend to do is we usually have a catch statement at the end. So we can say catch, error, and maybe we want to, once again, console.log, oh no, and we can concatenate this with the error message. So we will do this very often, and we won't just console.log the error message. We will want to do more with it, but we usually have a catch at the end of our promise chain to make sure that we are catching any errors that could come up. And this will essentially just do that. It will catch any errors. So for example, if I had a then in the middle here, and this then took in the value, and what it's going to do is it's going to throw a new error, and this error is going to have a message, something went wrong. Then the catch statement below is actually going to catch this error. So what actually happens here is that when we throw an error, it is rejecting the promise for us. So that means that this then is returning a rejected promise, meaning that we will never get into the .then console.log, but we will get into this catch statement. So you'll see now we log out, oh no, error, something went wrong. However, the catch doesn't actually need to be the end of our chain. So what we can do is let's make this catch a little bit larger. And instead of just console logging, let's actually also return a value of, let's say, 10. And now what we could do is we can chain another .then. So maybe this .then for now, let's just console.log. And of course, if this was actual code, we could just console.log here. But to illustrate the purpose of this, we can add a .then after the catch. And now you'll see we log out, oh no, something went wrong. But then we also log out 10 because this catch statement returned 10. So it returned a promise with the value of 10 that was fulfilled, meaning that we did get into this .then, and we were able to pass in the value of 10 to console.log. Now there's also one more function we can use here, and that is going to be finally. And finally works just like then and catch, with the one difference being that it does not get the value or the error message as a parameter. So it takes no parameters to its callback function. But what's nice about finally is that it will always run regardless of if the promise was fulfilled or rejected. So once the promise is settled, meaning no longer pending, the finally block will run. So for example, we could console.log out done, and now we can run this code and you see we get done. But even if we never caught the error, so if we get rid of this catch block, we are still going to end up logging out done. And of course, we still threw the error, so we still have an error message in the console, but we did log out done, so we got to this finally block. But for now, I will uncomment this code out, so our code is no longer throwing an uncaught error. Okay, so next what I want to look at is a few more promise functions that we can use to make dealing with promise code a little bit easier. So the first one is going to be promise.all. And what promise.all does is it takes in an array, and this array is going to be an array of promises. So for example, I could pass in this value of promise.resolve like this. And what promise.all does is it actually returns a new promise. So for example, I could then do .then and console.log out the value of this new promise. So now what I'm going to do is get rid of this code below here, scroll back up, and you'll see that we log out an array with the value of just 3. But if we had one more promise in this array, then what you'll see is we get 2 3s, and if we change this value to 2, we get the value of 2. So essentially, this is just logging out an array with all of the values from these different promises. So now you might be thinking, what's the point of this promise.all function? But what's nice about it is that it waits for all of the promises to finish, so for all of them to settle. So for example, let's add one more promise, but in this one, let's do a new promise. And inside of this promise, let's add the resolve and reject parameters. So oftentimes you'll see them as just res and rej. And what I'm going to do here is add a set timeout. And we are going to, in this set timeout, resolve the promise to a value. So we can resolve it to, say, the value of 5, but we are going to wait for a second before doing this. And now you'll see nothing happens for a full second. So promise.all is waiting for all of the promises to be resolved. And if any of the promises in promise.all reject, so for example, if we reject here, then this promise is actually going to immediately be rejected. So as soon as one of the promises in promise.all rejects, the whole thing rejects. So we could, for example, catch this rejection and let's say console.log out the rejected value, and you see now we log out 2. But again, if we resolve this promise, then once the timeout finishes running after 1 second and all 3 promises have resolved, we end up returning an array of the values that were resolved. So promise.all returns a new promise with an array as the value containing all of the resolved values from its promises in that array. We also have promise.race, and what this does is it's just like it sounds like, it's a race. So whichever promise resolves first is the value we get. So for example, this is going to log out 3 because this promise was first. However, let's make all of these be timeouts for a moment, and let's give them different times. So we can make this one be 2 seconds and this one be 3 seconds. And we will give these values of 3, 2, and 1. And then we need to add the commas at the end of these lines. And you will see that now we end up logging out 1. The reason we log out 1 is because 1 was the first promise to resolve. But if we rejected this promise, and let's say we just reject with the value of, oh no, we can just do this as a string, so you don't always need to have an actual error object. Usually we do, but sometimes you will see rejections and throwing with just a string or some other value. You'll see we end up logging out oh no because of the fact that we caught that error and we console logged it. If we had no catch, you'll be able to see that this actually did throw because of the fact that this one was rejected. However, this doesn't just happen when anything is rejected. So for example, if we rejected this promise, but then we resolved this one, and let's go back to resolving to a value of 1, you'll see we don't throw an error. The reason we don't throw an error is because it just forgets about these promises once this one has resolved. So the first promise to settle is the one we end up using. However, we could, instead of using race, we could use promise.any. And what this does is it is the first promise to fulfill. So right now, this is going to be the exact same. However, if we say rejected the first and second value and run this, what's going to happen is we actually end up logging out 3. However, we are never going to use these rejected promises. So promise.any is going to wait for any of the promises to have a state of fulfilled, and then it's just going to return that value. However, if none of them did fulfill, so for example, if we rejected all 3 of these values, then after the 3 seconds is up, you will see we do still end up having an error message, but this error message is not actually the value that we rejected. It's going to be an error that all of the promises were rejected in a promise.any. So it's sort of a different error that promise.any throws, but we can still catch this. So we could do .catch and say maybe we want to console.log all rejected. So once the 3 seconds is up, it's going to log out all rejected because all 3 of these promises had rejected states. Okay, so now I want to move on from just using promises with the then chains, and let's look at something called async and await. I'm going to get rid of all of this code and let's create a function. So I'm going to call this function, let's say tester, and all I'm going to do in this function is, let's say, return 3. And then let's call the function, so we can say console.log, let's say tester. And now, as you might expect, we end up logging out 3. But there's another keyword we can use here, and that is async. So we put the async keyword before the function keyword, and that marks the function as asynchronous. And an asynchronous function is simply one that will implicitly return a promise. So now you'll see we end up with a promise of a value of 3. So it's taking the return value and it's wrapping it in a fulfilled promise. Okay, so the idea of an asynchronous function returning a promise is nice, but that's not the only value we get out of them. What they also do is they allow us to use what is called the await keyword. And what await does is it waits for a promise to settle before it continues. So for example, I could say await a new promise. And this promise, let's pass in a function, resolve and reject. And we can say set timeout. And inside of this timeout, we are going to resolve the function. And we will resolve it to, let's say, that value of 3. And we can wait a second before resolving. And next, what we can do is we can save the result of this await into a variable or a constant. So for example, I could say const value and set it equal to the result of awaiting this promise. And then we could do something like console.log out the value. And now when we call the function, we don't need the console log here. We can just call tester. And you can see that after a second, we end up logging out 3. So this asynchronous function is just going to wait for the promise to settle before it continues running its code. This is the same thing as using the then function of a promise, the only difference being that we have a different syntax for it. And additionally, we can only use the await keyword when we are inside of an asynchronous function, or we can actually use it as well if we're at the top level of a module, but for the most part, we will just be using it inside of asynchronous functions, and we will never be able to use it in just a standard function. But now you might be asking, what if I wanted to catch an error here? How can we catch an error? And the easiest way to do that is simply to put it in a try-catch block. So we could say try, and we could wrap all of this code in the try, and then we will catch any errors. So we can say catch, and we can add the error, and then maybe we want to do the same console.log, oh no, and concatenate that with the error message. And then if instead of resolving this promise, we rejected it, and say we rejected it with a new error, something went wrong, and I'll go ahead and move this to a new line as well so we can see things a little bit easier. And now when I run this code, you'll see we end up logging out, oh no, and then we concatenate it with the string value of that error object, which is this error, the colon, and then something went wrong. And we can add a semicolon here at the end of this set timeout as well. Okay, now you might be saying, I don't want to use try-catch blocks. It means I have to indent my code more, and this doesn't look any cleaner. It looks worse. And you can actually combine the two syntaxes if you want. So what we can do instead is take this code, so take the promise, and I'm simply going to return it. So I'm going to return this promise. And now, rather than having this try-catch block, what we can do is when we call tester, we can use this as a promise because remember, asynchronous functions always return promises. So I can say tester.then, and in the .then, we can console.log, and this is going to console.log the value, just like we were doing here. And then in the catch, we can copy this code. So I can say .catch, and we can pass in the error and call the same code we had before. And now we can remove this try catch and run this code, and you will see we end up getting the same thing, oh no, and then we have the error, something went wrong. So this works the exact same way. Same thing if we were to resolve this promise instead. So no more new error, and let's resolve it to a value of 3. You'll see we end up just logging out the value of 3. Now that's going to do it for this video on promises within JavaScript. As you saw, there are a few different ways to do the same things, and it's sort of up to you which version you prefer if you want to use async and await versus then and catch. Async and await is the newer version, so a lot of people are using that now, but it is up to you. The main thing is just making sure you are being consistent. And we will see more examples of using promises throughout the crash course, particularly when we look at the fetch function and making calls to our APIs. But with that, that's going to be the end of this video. I hope you enjoyed it. I hope you learned something new, and I'll see you in the next one.